So this lesson is going to be a review of factoring. It's a common topic in Algebra 1. It comes up very little in geometry, but it is an especially important topic for Algebra 2. So in this lesson, I'm going to discuss the first type of factoring you should always try, which is greatest common factor. No matter how many terms the polynomial has, you want to make sure you're always looking for a greatest common factor first. The acronym that we use, or the abbreviation for this, is GCF. So you may have heard it before, but what it stands for is greatest common factor. Now, the greatest common factor will be a monomial. Monomial means one term. That one term can consist of a number, a variable, so for example, x or y or whatever the case may be, or it could be both together. So for example, you can have a number with an x next to it. Regardless, you need to make sure that you check that every term of the polynomial is divisible by that GCF. So here are a few examples that we'll work on, and then you'll go ahead and practice. So in the first one, we have two terms, 2xy squared and 10x squared y. Those are the two terms of that binomial. Now, as far as 2 and 10 is concerned, they are both divisible by 2. Then when you look at the letters, this one has an x and this one has an x squared. So what does that mean? That means this has 1x and this is the product of 2 x's. So you need to take the most amount of x's away from both of them. Now, a common quick shortcut is to just look at the exponents and to pick the smaller of the two. So if that were the case, this has an invisible exponent of 1 and this one other has an exponent of 2, which means if I use the smaller of the two, I would use an x. Now think of it this way. If I take 1 away from this term on the left, can I take 1 away from this term on the right? And the answer to that is yes. If I took 2 away from this term on the right, could I take 2 away from the term on the left? The answer to that is no. So the most x's you can take away is 1. Now, if you look at the y's, this is y squared, which means it's y times y, and this is just one single y. So again, the maximum amount of y's you can take away from each one of them is just 1. So there's a perfect scenario of a GCF that's a combination of numbers as well as variables. Now I immediately make a set of parentheses and I say to myself, well, if the original term or the original polynomial had 2 terms, I'm always going to end up with 2 terms inside of my parentheses. Now the way we do this is we divide each term by that GCF. So when you divide 2 by 2, you get 1. When you divide an x by an x, there are no more x's left. And when you divide y squared by y, you are left with just a y. Now, the operation between these two terms is an addition symbol, so therefore there's going to be an addition symbol between the two terms inside the parenthesis. Now we're going to divide 10x squared y by 2xy, and 10 divided by 2 gives us a 5. X squared divided by x leaves us with an x. And y divided by y gets rid of the y. So our final answer is what we have here. And I just want to point out that 2xy was considered the greatest common factor. Everything inside of this parenthesis is considered the quotient. That is the answer to what happens when you divide every term of the polynomial by the GCF. Now, a quick way you can check yourself here is through the distributive property. So you can distribute to check. So what I mean by that is, if you took 2xy and times it by 1y, you would have 2xy squared, which is the original term of the binomial. And then 2xy times 5x would be 10x squared y, which brings us back to the original polynomial. So here's our next one. Again, we have 2 terms. We need to look for what number can I divide them both by and what letter or letters do they have in common? So these two terms are both divisible by 3. And as far as variables are concerned, this one has an x times an x, and this one only has 1x. So the maximum you could take away would just be 1x. Now you make a set of parentheses, and you make a conscious effort to see how many terms there were in the original polynomial, which will determine how many terms you will have inside that parenthesis. Do division. 3 divided by 3 leaves us with 1. X squared divided by x leaves us with x. The symbol here is subtraction, which means that's what we will have here. That's because we're taking a positive number or a negative number divided by a positive number, which results in a negative answer. 9 divided by 3, 9 divided by 3 gives us 3, and the x's end up canceling out because an x divided by an x gives us a 1. So again, this is your factored form of the original polynomial. 3x is your GCF, and x minus 3 is your quotient. Now, these are both considered factors of 3x squared minus 9x. So 3x is one factor, and x minus 3 is the other factor. Those two multiplied by each other will give us back the original polynomial, which is what I mean by the distributive property. Number 3, we have 18xy and 27y squared. So as far as factors are concerned, they're both divisible by 9. Now, I'm going to try something here. They are actually both divisible by 3. And as far as letters are concerned, this has 1x and 1y, this has 2 y's. So you can't take any x's away, and the maximum amount of y's you could take away is just 1. Now, I'm making a silly mistake here just to prove a point. The original polynomial has 2 terms, so our quotient in parentheses will also have 2 terms. 18 divided by 3 leaves us with 6. The x remains because there's no x to divide it by, and the y will go away because y divided by y is 1. Now we have a positive second term, and a positive divided by a positive will result in a positive. 27 divided by 3 is 9. Y squared divided by y leaves us with 1y. Now, this is technically factored. It's just not factored completely, because although 3y was a common factor, it's not the greatest common factor. If you look at 6 and 9, they are also both divisible by 3. Which means the GCF was not 3y, the GCF was actually 9y. And if you think about that, the factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 27 are 1, 3, 9, and 27. So as far as the greatest common factor that they both have in common, that would be 9. So I'm going to do this again, except now I'll have the GCF as 9y, and I'll divide both terms by 9y, which means 18 divided by 9 leaves us with 2. The x will remain because there's no x to reduce it with. The y will go away. Y divided by y is 1. Again, you're going to have a positive second term because positive 27 divided by 9 will give you a positive 3. Y squared divided by y leaves us just with another y. This is factored completely because 9y was the greatest common factor. Okay, and then this right here is the other quotient, also known as the other factor. 2 more with a few more variables. The procedure doesn't stay the same, but it might get a little bit awkward to do in your head. So we're going to use what I discussed earlier. As far as the numbers, when we look at 5 and 30, the biggest number they're divisible by is 5. As far as letters, let's look at the exponents. The exponent of x there is 4. The exponent of of x here is 5. If you're going to pick the smaller of the two, you're going to make the exponent of x be the 4. And that's because this one has 4 x's being multiplied by each other. This one has 5. So the maximum you could take away from each one is 4 because the one on the left doesn't have the 5th one. Now, if you look at the y's, this one has 3 and this one has 4. So you're going to use the smaller of the two. So that means, as far as the greatest common factor, the y will have an exponent of 3. You make a set of parentheses. There are 2 terms in the original. There will be 2 terms in the answer. 5 divided by 5 is 1. X to the 4th divided by x to the 4th is theoretically also 1. So when you multiply 1 by 1, it stays a 1. And y to the 3rd divided by y to the 3rd is also 1. So this placeholder of 1 here is extremely important. Anything divided by itself is 1. I'm going to write this down. Anything divided by itself is 1. It doesn't go away. A lot of students will like to not put something in this first spot, but it's extremely important that you put the placeholder of 1 there. Now what I'm going to do here is just move over the 1 so it's centered a little bit better on that line. Okay, now we have a positive second term. So a positive divided by a positive will be positive. 30 divided by 5 is 6. This had 5 x's, and we really are only removing 4, which leaves us with an x. This has 4 y's, but we're only taking away 3 of them, which leaves us with a y. So these are your factors completely factored. Last one, this is a trinomial. So this will be a little bit different in the sense where we'll have to do division 3 times. But as far as numbers, same thing goes. You look at 6, 9, and 18 and ask yourself what the biggest number they're divisible by is. Factors of 6 are 1, 2, 3, and 6. Factors of 9 are just 1, 3, and 9. Factors of 18 are 1, 2, 3, 6, 9, and 18. The biggest number they are all divisible by looks like it's going to be this 3. Now, the right two have a 9 in common, but the 6 is not divisible by 9. So 3 is the GCF as far as numbers are concerned. But now let's look at our variables. So x here is x squared. This x is really an x to the first. This one doesn't even have any x's. So if all 3 do not have something in common, you cannot take it away. So there are not any x's in common, therefore we move on to the y's. As far as the exponents of the y's, this one is a 3, this one is a 4, and this one is a 5. You're going to use the smallest of those exponents. So out of 3, 4, and 5, 3 is the smallest. It's okay that they don't all have an x in common. That's totally fine. Notice I made my set of parentheses wider because there are going to be 3 terms going in here because the original polynomial was a trinomial. So 6 divided by 3 gives me 2. X squared is not going to change because there are no x's to remove. Y cubed divided by y cubed is 1. So anything multiplied by 1 stays the same. So we're going to leave that there. Now you have a positive divided by a positive, which results in a positive answer. 9 divided by 3 is 3. X does not go away because there are no x's to divide by. Y to the 4th divided by y cubed, well, you're taking 3 of those 4 away, leaving you with 1 more y. Again, you have a positive term, so our answer will be positive. 18 divided by 3 is 6. This term had 5 y's, but we're only removing 3, leaving us with y squared. So this is your factored form of the original trinomial. Notice that the GCF is the largest term that every term of a polynomial can be divided by. When working with variables, choose the lowest exponent of any variable that they share. It will look like this when you are done. Again, remember, if the original polynomial is a binomial, your quotient will have 2 terms. Will be 2 terms. If the original polynomial is a trinomial, your quotient will have 3 terms. Your GCF can be a combination of numbers and letters as long as every term of the polynomial shares those letters. So this is a review of greatest common factor. I hope that you do well in the practice.